Have you ever gazed up at the night sky and wondered, how did all this come to be? As you stand beneath the cloak of darkness, you find yourself in the theater of the cosmos, a grand spectacle that leaves you spellbound. An endless expanse dotted with glittering jewels, the universe is a masterpiece of cosmic artistry. Its vastness is beyond human comprehension, stretching across billions of light years, filled with countless galaxies. And within each galaxy there are millions, even billions of solar systems, each a unique assembly of celestial bodies. This cosmic neighborhood of ours is just one among many, an example of the universe's staggering diversity. What makes each solar system so unique? How do stars, planets, moons, and asteroids come together to form these celestial symphonies? These are the mysteries that have fascinated astronomers for centuries. Today, we'll unravel the fascinating process of how a solar system is born. Our story begins in a place much like the one we're in, a galaxy spinning in the vastness of space. As we traverse the cosmos, we encounter an intriguing phenomenon: cosmic dust. These minute particles are the unsung heroes of the universe, scattered across the vast expanse of space. Cosmic dust is not just dust, it's a cocktail of elements. A pinch of this cosmic dust contains everything from iron to carbon, the building blocks of life as we know it. Now, imagine countless particles of cosmic dust, along with gas, gathering in the cold, dark corners of the universe, forming massive clouds. These aren't your everyday fluffy white clouds. Oh no, these are nebulae, immense celestial bodies light years in size. They're silent yet brimming with potential, acting as the grand nurseries of the cosmos. In these nebulae, something extraordinary happens. The dust and gas start to dance together, pulled by the universal rhythm of gravity. As they dance closer and closer, they form dense pockets within the cloud. These pockets are the seeds of stars and planets, the fundamental kernels of solar systems. But how does a seed become a star or a planet? Well, it all comes down to pressure. As more and more material is drawn into these pockets, the pressure at their cores increases. In the heart of a star-to-be, the pressure becomes so intense that hydrogen atoms begin to fuse together, releasing energy in the process. This is nuclear fusion, the process that powers every star in the universe. For a planet to be, the process is a little different. Instead of nuclear fusion, the pressure triggers the clumping together of dust and gas, forming a solid core. Over time, this core attracts more and more material, growing in size until it becomes a planet. In these cosmic nurseries, the stage is set for a spectacle of astronomical proportions. The cosmic dust and gas clouds are more than just specks in the universe. They are the creators, the sculptors of stars and planets, the architects of solar systems. They are the testament to the beauty, complexity, and sheer wonder of our universe. In the heart of these dust clouds, something extraordinary begins to happen. You see, the universe is not simply a vast expanse of nothingness. It's a place of constant creation and transformation. Within these cosmic dust clouds, the seeds of stars are sown. Let's imagine a cosmic cloud, a colossal entity of dust and gas that spans light years. Within this cloud, gravity, the invisible force that keeps our feet on the ground, begins to work its magic. It pulls this dust and gas together, creating clumps. These clumps become denser and denser, growing larger over thousands of years. It's like a cosmic dance, with gravity leading the way, pulling, tugging, and shaping matter into something new. As these clumps of matter grow, the pressure and temperature at their core also rise. This is where the magic truly begins. When the core's temperature reaches a staggering 10 million degrees, a process called nuclear fusion ignites. In the simplest of terms, nuclear fusion is when hydrogen atoms collide with such force that they stick together, forming helium. This process releases a tremendous amount of energy, creating heat and light. At this point, the clump of matter has transformed. It's no longer a simple clump, it's a protostar, the infant stage of a star. Yet, it's not a star just yet. The protostar continues to grow, feeding on the surrounding dust and gas. It's a cosmic toddler, growing and learning, all under the watchful eye of gravity. Eventually, the protostar reaches a point of equilibrium. The outward pressure created by the heat of nuclear fusion balances the inward pull of gravity. It's a delicate dance, a balance that will define the life of the star. And with that balance, the protostar sheds its infantile skin. It becomes a main sequence star, a fully formed celestial body that lights up the cosmos. And thus a star is born, but our tale is far from over. Around this newborn star, a dance of creation begins. What may seem like a cosmic ballet is, in fact, the first steps towards the formation of planets. Amidst the celestial glow of the star, the leftover dust and gas start to perform a gravitational waltz. Small particles within this cosmic cloud begin to coalesce, drawn together by their mutual gravitational attraction. These particles, mind you, are not just any particles. They are the remnants of our star's birth, a mix of elements that once ignited the star's fiery heart. Now, they are the builders of new worlds. As these particles merge, they form clumps, not much bigger than a grain of sand at first. But with each passing moment, these clumps grow, attracting more and more material. This process is slow, taking millions of years. But in the grand scheme of the cosmos, it's but a blink of an eye. These clumps continue to grow, from the size of pebbles to boulders, and then to mountains. They become planetesimals, the seeds of planets. The planetesimals continue their dance around the star, colliding and merging with others, growing larger and larger. Some of these planetesimals have a lucky fate, growing into the size of moons, and then planets. Their gravitational pull becomes so strong that they clear their orbit, gathering all the dust and gas in their path. This is the time when the dance slows down, the music fades, and the stage is set. The planets have found their place around the star, each in its own orbit, revolving in a synchronized rhythm. They are now part of a larger family, a solar system, each member unique, yet bound by the same gravitational ties. The dance of creation may seem chaotic, even violent at times, but it's this very chaos that brings about order, that gives birth to worlds, to life. And just like that, we have a solar system, a star with its family of planets. From a cloud of dust and gas to a bustling solar system, the journey is truly awe-inspiring. Such grandeur, such magnificence born from the simplest and most humble of beginnings. It's a process that takes millions, even billions of years. Looking back at the stages, we see the cosmic dust, the very building blocks of everything we know, swirling, colliding and clumping together. Then, the birth of a star, a fiery spectacle that illuminates the cosmos, born from the intense pressure and heat of the collapsing dust and gas. The formation of planets, those celestial bodies that revolve around the star, is another spectacle. Fragments of rock and ice, over time, coalesce into spheres, each with its own unique characteristics and potential for life. This process, this beautiful dance of creation, is happening right now in countless corners of the universe. So, next time you look up at the night sky, remember the incredible journey each star and its planets have taken to be there.